Okay, so continuing in section 3.5, we're going to look at some examples of how to actually find the vertical and the horizontal asymptotes. Okay, so here's our first example. I know I'm calling it example 3, so just ignore that. This is our first example. So we have a rational function, g of x, is equal to 3x plus 4 over x squared minus 2x minus 8. So if that's not clear, let me just write it down again. G of x, we have 3x plus 4, that's the numerator, divided by x squared minus 2x minus 8. Okay, so we want to find the vertical and horizontal asymptotes. Let's start with the vertical, right? So for the vertical, the first step here is to simplify the rational expression. So simplify, if you remember, means two things. You have to factor and we have to cancel. Okay, so let's factor the numerator, 3x plus 4. Okay, trick question. We can't factor it, right? It's already prime. It's already irreducible. There's nothing to factor, right? So it's like a prime number. So 3x plus 4, that's the best we could do. That's already prime. What about the denominator, right? So now we have to factor the denominator. X squared minus 2x minus 8. So you should have done this many times last semester. When you want to factor something, you look for the GCF. In this case, the GCF is just 1. And for a trinomial, we look for, hang on, let me try it this way. We look for two numbers, right? This is going to be x times x, whose product is negative 8 and whose sum is negative 2. You got it? So it's not going to be, negative 8 and 1. It's going to be negative 4 and positive 2. So we can check. Negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2, right? So that's the denominator. In its factored form, x minus 4 times x plus 2. Okay. So now that we have the numerator factored, well, it's already factored. That was given it to us that way, because it's prime. And then we factor the denominator, right? Okay, so now what? Step 2 in this process is to set the denominator equal to 0 and solve for x. Oh, I forgot about step 1, cancel. Obviously nothing cancels here, right? There's nothing that's the same in the numerator and denominator. So that doesn't always happen, but right here there's nothing to cancel. Okay, so back to step 2. Set the denominator equal to 0 and solve for x. So the denominator is just, well, I'll write it here again, x minus 4 times x plus 2 equals 0. So obviously in factored form it's a lot easier to solve than it would be here if we left it this way. Obviously you could just use the quadratic formula. That would work too. But in this case you just set each factor x minus 4 equal to 0 and then x plus 2 equal to 0. And when you solve x minus 4 equals 0, you get x equals positive 4. And when you set x plus 2 equal to 0, you get x equals negative 2. And there we go. These equations are the vertical asymptotes, right? So these are the vertical asymptotes of the graph of this function. So if we were to graph this function, one way to do it is to graph the asymptotes, right? Graph these lines and then figure out where the graph is approaching, right? Figure out how it's approaching these lines. But we're not interested in actually graphing the function. We just want to find the vertical and horizontal asymptotes, and we found the vertical asymptotes, right? All right. But it also wants the horizontal asymptotes. Okay, so that's a different procedure here, right? So let me go back to the original function here, right? So now we're going to look for the horizontal asymptotes, 3x plus 4 over x squared minus 2x minus 8. So this was the original function that they gave us. And in fact, we want to leave it in its standard form. Both the numerator and denominator should be multiplied out, not in factored form, right? Okay. So notice there's three cases here, right? So n and m. So what were n and m? So n is the degree of the numerator. That's the n right here, right? And the m is the degree of the denominator. That's the m right here, right? So in other words, the n is just the biggest exponent of the numerator, and the m is the biggest exponent in the denominator. Okay? So looking at this function here, what's the biggest exponent in the numerator? The numerator is 3x plus 4. Sorry, that's a 4. So the biggest exponent is just x to the 1, right? So in other words, n, I feel like I got this backwards, but right, n is 1, right? Right. There's an invisible, x to the 0, but the biggest exponent is 1. So the degree of the numerator is 1. Right. What about the degree of the denominator? So again, we have x to the 0, x to the 1, but the biggest power, which should be in front, right, is the 2. So m is equal to 2. Okay. So now let's compare these two numbers. Which one's bigger, right? Which one's bigger? M is 2, and 2 is bigger than 1, right? So in other words, n is less than m because 1 is less than 2. So that means we're in case 1 here. This is case 1 right here, right? So in case 1, if n is less than m, and that's exactly what's happening here, then y equals 0 is the horizontal asymptote. So there's really nothing to calculate. It's just figuring out whether the degree of the numerator and the degree of the, which is bigger, the degree of the numerator or the degree of the denominator. If the degree of the numerator is less than the degree of the denominator, as it is here, then all you have to say is y equals 0 is the horizontal asymptote. And we're done. Okay. So, So there's one horizontal asymptote, y equals 0, and there's two vertical asymptotes, x equals 4 and x equals -2. So I hope that helps. That's the first example here. Okay, so let's do one more example for finding vertical and horizontal asymptotes. Oh, and I forgot to find where the graph crosses the horizontal asymptote. All right, we'll come back to that. Right now, let's just find the vertical and horizontal asymptotes for this example here. So here we have a function, g of x, and that's equal to 2x squared minus 8 all over x squared plus x minus 2. All right, so let's start with the vertical, right? Let's do vertical first. How do we find the vertical asymptotes? Well, we have to factor the numerator and the denominator. So let's start with the numerator. We can factor out a 2. In fact, let's do that up here. So 2x squared minus 8. If you factor out a 2, you get 2 times x squared minus 4. So now you see why I didn't write that here yet, because we can factor x squared minus 4 as the difference of two perfect squares, right? A squared minus b squared, which is just a minus b times a plus b. Or in this case, x minus 2 times x plus 2. So, okay. Now for the denominator, we have x squared plus x minus 2, and so this will be another trinomial factored as the product of two binomials. What two numbers multiply to -2 and add to +1. So you could do -2 and then +1, but I think that would add to -1. We want to add to +1. So we want the bigger number to be positive. So x plus 2 times x minus 1. Okay, so that's the factoring part, right? The next step is to simplify, right? In other words, we want to cancel any common factors. So unlike the previous problem where we did not have any common factors, here we do, right? Notice that the x plus 2 in the numerator here is the same as the x plus 2 in the denominator. So we can cancel these as your common factors, and so after we cancel those, we end up with 2 times x minus 2 all over x minus 1, right? And in fact, we can multiply this out again. We get 2x minus 4 in the numerator divided by x minus 1. So this is the simplified version of this function here, this expression here. Okay, right. Now we set the denominator equal to 0, right? So take the x minus 1, set it equal to 0. You can solve that in your sleep, right? Just add 1 to both sides, you get x equals positive 1. And guess what? We're done, right? This is our vertical asymptote. Right? Right. So you have to be careful here, because if you noticed, if you didn't cancel these, you might be tempted to set x plus 2 equal to 0 as well. And in that case, you would get x equals negative 2. But you have to be careful here, because this is not a vertical asymptote. Right? It got canceled. So, right? So that's the difference between, asymptote. That's the difference between asymptotes and the domain, right? If you were finding the domain of this function, and maybe we should have done that, but let's do it now. If you want to find the domain, right, before you simplify it, right, in this version here, you would set both of these equal to 0, and you would get two solutions. X minus 1 equals 0. So you would get x equals negative 2 and x equals positive 1. And both of these would have to be excluded from the domain, right? So in other words, the domain will be, well, one way to write it is the set of all x such that x does not equal negative 2 or positive 1. Or you remember an interval notation from negative infinity to negative 2, and then from negative 2 to 1, and then from 1 to infinity, taking their unions in between. Okay, so yes, so the domain has to exclude the negative 2. However, the negative 2 does not become a vertical asymptote because it got canceled, right? So if you remember, right, you have to cancel first before you set the denominator equal to 0. So notice that nothing canceled here. So in the first problem, both of these factors, when you set them both equal to 0, we got two vertical asymptotes. In this example here, even though we got two factors in the denominator, one of them canceled, and so that becomes, that means there's only one vertical asymptote, and it's just x equals 1, right? Okay, so that's the difference between these two examples. The first one, nothing canceled, so we get two vertical asymptotes here. One of the factors canceled, and then the one that's left over then, the x minus 1, that became our vertical asymptote. Okay, so all right, so that's vertical. What about horizontal asymptotes, right? So for the horizontal asymptote, remember there's these three cases. The first example, it was case 1, where n was less than m. So let's find the n and m for the second example. Right, so yep, so let's do horizontal asymptotes now. If I can spell. And I'm just going to abbreviate asymptote, ASY, right? So these are going to be horizontal lines, y equals something. And so here we have to compare the degree of the numerator and the denominator, right? So in this case, the degree of the numerator is the 2 here, so n is 2. The degree of the denominator, notice, is also 2, so m equals 2. Right. Now you might ask, well, why didn't I use the simplified version and compare those? So you do get different n and m's here, right? Here your n is 1, right? And here your m is also 1. So if you used the simplified version, while you get different numbers, the result is the same, because in both cases n equals m, right? 1 equals 1 or 2 equals 2, right? So either way, it doesn't matter whether you use the simplified version or the non-simplified version. And the reason is because if something cancels from the numerator, it also cancels from the denominator. So you're reducing the degree by 1 by canceling. Okay. So what does that mean, right? So now we're in case 2 here, where n equals m, right? And in this case, it's a little more complicated. We have to actually divide the leading coefficients of the numerator and denominator. Okay, so the leading coefficient here for the numerator, highlight that here, the leading coefficient here, the an, if you will, is just 2. So we're going to get a horizontal asymptote of y equals, right, in general, an over bn. Well, it's m, except that in this case n equals m, so they're the same. So the an we just said was 2, and the bn is the number in front of the x squared. So it's invisible, but it's a 1, right? So 2 divided by 1, of course, is just 2, right? So that means we have a horizontal asymptote of y equals 2. Okay, so yep, this is our horizontal asymptote. Okay, so yes, when the degrees are equal, as it happens here, whether you use these degrees or these degrees, 1s or 2s, they're both the same. And so that means we're in case 2, which means we have to actually take the leading coefficients and divide them. Why didn't we do that here, right? Why don't we deal with the 3 and the invisible 1 here? Because that's case 1. In case 1, it doesn't matter what the coefficients are. It's just y equals 0 when the degree of the numerator is less than the degree of the denominator. Okay? So yeah, we don't need the 3 and the 1 here. But when the degrees are equal, right, when n equals m, right, then you have to divide the leading coefficients. That's the 2 over the 1. And by the way, we could have taken the 2 over 1 here as well. There's this 2 and this 1. It gives you the same answer either way. Okay? Right. But when you're finding the vertical asymptote, you have to use the simplified version for the denominator, to set the denominator equal to 0 here, as we did here. Right? Okay, so I hope that helps. These are 2 examples of finding vertical and horizontal asymptotes, right? And in the directions, well, I copied them here, or I crossed them out here, I guess. But we also want to find where the graph crosses the horizontal asymptote. So we didn't do that in the first example. Maybe we should go back to that. And this doesn't usually happen, but it's something that you might want to look at in some problems where they might specifically ask where does the graph cross the horizontal asymptote? And I should also say that they're never going to ask where the graph crosses the vertical asymptote. In fact, this is very important, so let me write this down. Graphs can never cross vertical asymptotes. Asymptotes, yes. Right. Graphs will never cross a vertical asymptote. If a graph crosses a vertical asymptote, then it wasn't an asymptote to begin with, right? So when you have a vertical line, right, like this, for it to be an asymptote, right, the graph can get close to it, but it can't ever cross it. Okay? So it can get close to it from both sides, right? So it might look like this, for example. But it's not going to cross it, right? So it can't do that. Okay? Oops, sorry. All right. So, yeah, so this dotted red line here could be a vertical asymptote. But it can happen that a graph crosses horizontal asymptotes, and usually it doesn't, but in some problems, I shouldn't say it's rare, but in some problems it could. So how do we determine if it crosses the horizontal asymptote? Well, here the horizontal asymptote is just y equals 0, right? So where does the graph, this graph here, go back to g of x here. So that was 3x plus 4 over, yep, x squared minus 2x minus 8. To say where does it cross the horizontal asymptote is to set it equal to the horizontal asymptote. In this case, the horizontal asymptote is 0, y equals 0, right? So we just have to solve this equation. And the easiest way to solve it, because it's a rational equation, is to multiply both sides by this denominator, right? You get 3x plus 4 on the left, plus 4, and you get 0 times x squared minus 2x minus 8. Well, 0 times x squared minus 2x minus 8 is just 0. So now we just have to solve the equation 3x plus 4 equals 0, and you can do that. You get x equals negative 4 over 3. So in this case, the graph does cross the horizontal asymptote at, well, x equals 4 over 3. Yeah, do it this way. So at x equals negative 4 over 3, and y equals, well, 0, right? Y equals 0. That's the horizontal asymptote. So that's the point on the graph where the graph crosses the horizontal asymptote. And in fact, this is also, of course, an x-intercept. So remember, when you set the numerator equal to 0, right, but not the denominator, in this case, you're finding where the graph crosses the horizontal asymptote, but because the horizontal asymptote was just the x-axis, right, this is also, oh, I already just said that. This is also an x-intercept. Okay? All right. So that's for the first example. That's where the graph crossed the horizontal asymptote. What about for the second example? Right? So now, where does the graph cross the horizontal asymptotes? So here, the horizontal asymptote is y equals 2. So now we set either the original function equal to 2, but I would prefer we used this version, the simplified version, right? Set this equal to 2. Right? So let's do that down here. So again, we're finding where the graph crosses the horizontal asymptote. So this is the graph of 2x minus 4 over x minus 1. And we want to know where does that equal 2, because that's the horizontal asymptote. Right. So I'll write 2 over 1. And so we have to solve this equation for x. And the easiest way, so here we can multiply both sides by the denominator, x minus 1, or just cross multiply. So 2x minus 4 is equal to 2 times x minus 1. And then the other side, 1 times 2x minus 4 is just this. So how do we solve that equation? Well, 2x minus 4 is on the left. On the right, you get 2x minus, right, 2 times negative 1 is negative 2. So 2x minus 2. So now we can subtract the 2x from both sides, cancel those, and we end up with negative 4 equals negative 2, which is absurd, right? Negative 4 does not equal negative 2. In other words, this equation here has no solution. So the conclusion here, remember the question was, where does the graph cross the horizontal asymptote? And in this case, we can say definitively that the graph does not cross the horizontal asymptote. Does not cross the horizontal asymptote. Right. So where does it cross it? Nowhere, right? And that's usually the case, although in the first example, if you remember the first example, the graph does cross the horizontal asymptote just once, right? And usually it'll cross just once. It could cross many times in several places, but usually just once. So I hope that helps for at least these two examples. And maybe I'll do one more just to cover all the bases here, because there's actually 3 cases for the horizontal asymptote. We did case 1 and case 2, but there are examples where we have to use case 3. So we'll do that next. Okay, so one last example, right? So here we have a function f of x equals x squared plus x over x plus 2. If that's not clear, I'll just rewrite it. So this is x squared plus x all over, x squared plus x all over x plus 2. And again, we want to find the vertical and horizontal asymptotes. So let's start with the vertical. So remember the process to find the vertical asymptotes. We're going to have to factor numerator and denominator. From the numerator, we can just factor out an x. The greatest common factor is just x, so factor it out. X times x plus 1, right? There's an invisible 1 there. And the denominator, x plus 2, is prime. There's nothing to factor out of x plus 2. Okay. So now we cancel any common factors. I don't see anything common to the numerator and denominator, so nothing cancels here. So it's already simplified. So now we just set the denominator equal to 0. Here the denominator is just x plus 2. So when you set that equal to 0, we get x equals negative 2. And that is our vertical asymptote. Yep, just 1 in this case. X equals negative 2. Okay. So now let's move on to the horizontal asymptote. Right? And to do that, we have to go back to the original, x squared plus x over x plus 2, and compare the degree of the numerator with the degree of the denominator. Here, the degree of the numerator, the n if you will, is 2. So n is equal to 2. The degree of the denominator here is 1, so m is equal to 1. Okay, so we are in a case where n is bigger than m, because 2 is bigger than 1. So this is actually case 3. So I have to go way back up here and look at what happens when we're in case 3 here. So n is bigger than m. Well, the conclusion is that there is no horizontal asymptote. Right? So there doesn't have to be. So essentially that's our answer here. Right? So this graph has no horizontal asymptote. None, right? None whatsoever. Does have a vertical asymptote, but no horizontal asymptote. So that's what happens when you're in case 3, when the degree of the numerator, the exponent on top is bigger than the exponent on the bottom, then the conclusion is that there's no horizontal asymptote whatsoever. Although there could be what's called a slant asymptote. And in fact there is here, but we're not going to find it. So we're not asking for slant asymptotes. That's going to be, you'll do that in your next course in pre-calculus. Yeah, we're just interested in the vertical and horizontal asymptotes. So the vertical is x equals negative 2, and the horizontal is none. There is no horizontal asymptote. But there is a slant asymptote, and we're not going to ask for those. We're not going to ask for slant asymptotes in this course. So we just say there's no horizontal asymptote and leave it at that. So I hope that helps with these 3 examples here.